This is our trig lesson for e-learning Monday, March 8th. We are going to be using inverse properties with the sine, cosine, and tangent functions. This is where we're actually doing composition of functions. And if you take a look here, you're going to see that for each trig function, we have two statements. And depending on the order of your composition, you're going to get an output which is equal to x, the input, if the input is in a certain interval. So for instance, for the sine function, you see the sine of the inverse sine of x equals x, as long as x is in the interval from -1 to +1. What's happening is the sine is undoing the inverse sine. The inverse sine is trying to find the angle that has a given input value between -1 and +1. And as long as the value's between -1 and +1, when you find that angle and you take the sine of that angle, that's going to return the original input value between -1 and +1. So that's why you see it equal to x. The key is being between -1 and +1. In the second composition, you are taking the inverse sine of the sine of x, and it will equal x as long as x is in the interval from -π/2 to +π/2. That's because here you're taking the sine of the angle and getting a value, and that value is a unit circle value, and then we're saying find the angle that has that given sine angle or that sine value. And so here, if the input, as long as the input's between -π/2 and +π/2, you're going to get that same output. So we're going to see some problems here below, but this is going to hold true for the cosine function as well as the tangent function as well. The key is the x for the original input is in the given interval. So for instance, the cosine of the inverse cosine of x will equal x as long as that input is between -1 and +1. And in the inverse cosine of the cosine of x, it will equal x as long as the input is between 0 and pi. And that's simply here because the inverse cosine is only defined between 0 and pi. That's true up here as well for the inverse sine. It's only defined between -π/2 and +π/2. Then we go to the tangent. The tangent of the inverse tangent of x will equal x for all values of x, because that when you think of the original tangent function, the range is all reals, and so that's the input for the inverse tangent function. And so it doesn't really matter what that input is, that's going to give you the same output. For the inverse tangent of the tangent of x, that will equal x as long as you're between -π/2 and +π/2. And that's because that is in the range of the inverse tangent. It's going to be much simpler when you actually see some problems. So these are key values. We'll look out for them as we do problems. Let's take a look at some problems to help this make sense. So the first problem says, and the directions say, find the exact value of each expression. If possible, do not use a calculator. So it says the inverse sine of the sine of π/3. So π/3 is between -π/2 and +π/2. We could find the actual value of the sine of π/3. It's square root of 3/2. And then say, find the angle that has the value of square root of 3/2. But we don't really need to do that because the inverse sign is going to undo taking the sign. And so the output's going to be pi over 3. As long as that input is between negative pi over 2 and positive pi over 2, as it indicates above. How about number 2? Number 2 has the order reversed. It says find the cosine of the inverse cosine of negative square root of 3 over 2. Of course, the cosine is going to undo finding the inverse cosine, and we know that the inverse cosine is going to give an angle that has a cosine value of negative square root of 3 over 2. Does it matter what that angle is as long as the input is between negative 1 and positive 1? The answer is no, because when you take the cosine of the angle, it's going to return that same value of, negative square root of 3 over 2. That is a unit circle value, so we don't really have to find the angle. We could find the angle, but we don't need to. How about the cosine of the inverse cosine of 1/2? Again, the cosine is going to undo the inverse cosine. We could find the angle that has a cosine value of 1/2, but when we take the cosine of that angle, it must return that same value as long as that value is between negative 1 and positive 1. How about the tangent of the inverse tangent of negative 1? So we would be saying find the angle that has a tangent of negative 1, and then take the tangent of that angle. Again, there's no restriction on the input with the inverse tangent. It can be any real number, and so the output would be that value as well, because it really doesn't matter what angle it is, it's going to have the same tangent value. How about number 5? The inverse tangent of the tangent of pi over 4. Well, we could find the tangent of pi over 4. We probably know it's 1. And then finding the inverse tangent of that value is going to have to be that angle as long as it's between negative pi over 2 and positive pi over 2, which pi over 4 is. Then we come to the inverse cosine of the cosine of 3 pi over 2. And this is the first one that I will point out throws up a red flag. Why? Because 3 pi over 2 is not between 0 and pi, which is the input or the output for the inverse cosine, which we're going to have to do second. So we can actually find the cosine of 3 pi over 2, but since it's not between 0 and pi, we actually need to find that value, and that means we are going to find the inverse cosine of 0, because at 3 pi over 2, the cosine value is 0, and then when we find the inverse cosine, that is pi over 2. So that problem's a little different simply because the angle is not between 0 and pi. So I can't say the answer is 3 pi over 2. I'm finding the angle that has the same trigonometric value as 3 pi over 2, but is in the range of the inverse cosine. And that would be the angle pi over 2. How about number 7? In number 7, we're finding the inverse sine of the sine of 5 pi over 6. Again, we've got a problem because 5 pi over 6 is not between negative pi over 2 and positive pi over 2, meaning my answer is not going to be 5 pi over 6. I can find the sine of 5 pi over 6. It's in quadrant 2. It would be 1/2. And then I would take the inverse sine of 1/2. And this is where I'm going to give the angle between negative pi over 2 and positive pi over 2 that has the same output of 1/2. And that would be pi over 6. Finally, the last one, the sine of the inverse sine of 2.3. The red flag there is the value of 2.3. It is not between -1 and +1. Therefore, we can't find an angle that has a sine of 2.3, and we can't find the sine of that angle. Therefore, this is undefined. So when we look here at what happens, in most instances, the first 5 problems, the output was the same as the input in the composition because you were undoing what you were doing in the first step. The inverse sine of an angle or the cosine of the inverse cosine of a value. And as long as you were between these values up here, right here, you got the same outcome. But when you deviated from that in problems 6, 7, and 8, that's where you had to be careful. So like in 6, we had to find the cosine of 3 pi over 2 first, since 3 pi over 2 is not between 0 and pi. And in number 7, 5 pi over 6 is not between -pi over 2 and +pi over 2, so we found that value first, and then we found the inverse sine. It really depends on the problem. You could always do it as a 2-step process, but you don't have to if you understand the restrictions on the functions that we see above. All right, so that is your lesson. The assignment's not going to be that difficult because it's more cerebral. You have to think a lot, but the homework is 4.7b in my math lab. And then on Tuesday or Wednesday, we will finish up 4.7 and begin 4.8. Have a great day. We will see you next time.